Welcome to Star Chat, the podcast that explores the wonders of the universe and our place within it. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. Today, we're going to talk about a fascinating discovery that's causing scientists to rethink how and when our solar system formed. You see, for a long time, we've believed that small rocky bodies called protoplanets formed throughout the solar system. But those found beyond the asteroid belt between Mars and Jupiter came together a bit later than those further towards the center. This difference was thought to be because the outer bodies had more water and ice, which slowed down the melting of an inner core. But now, a team of researchers has made a groundbreaking discovery that's challenging this long-held theory. They've been studying a small meteorite called Northwest Africa 12,264, which weighs around 50 grams and was purchased from a dealer in Morocco in 2018. By analyzing tiny particles shaved from the object, they found that the ratio of chromium and oxygen proved that the meteorite originated in the outer part of the solar system. What's even more remarkable is that the composition of the meteorite showed it was part of a planetary mantle, the section between the core and crust, making it the first such sample found from the outer part of the solar system. And here's the kicker. Its age, as measured by isotopes of lead, went against the idea that outer protoplanets should be younger. In fact, it's one of the oldest materials in the solar system. This discovery has significant implications for our understanding of how the solar system formed. It suggests that the rocky planets formed in the inner and outer solar system at the same time, which could force a rewrite of the models we use to understand this process. As Sebastian Cried at the University of Exeter, UK says, "These formative stages are very short, and a million years can make a big difference. Getting the chronology right and getting the order of things right is very important." As we ponder the significance of this discovery, let's take a step back and appreciate the vastness of the universe and the complexity of its history. The fact that we're still uncovering secrets about our own solar system is a reminder of how much we have yet to learn. And it's discoveries like these that inspire us to keep exploring, to keep seeking answers to the big questions that have puzzled humans for centuries. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. I'm your host, Carl. We're exploring the wonders of the universe, and today we have a fascinating tale that's out of this world. Imagine a planet so close to its star that it's not just feeling the heat, but actually causing its own demise. Let me tell you about HIP 67522b, a Jupiter-sized planet with a density similar to cotton candy, making it one of the wispiest exoplanets ever found. Located in a nearby universe, this planet orbits extremely close to its host star, HIP 67522. Now, you might think that's not unusual, but what's remarkable is that this planet seems to be triggering flares of radiation from its star. Yes, you heard that right. The planet is causing the star to erupt in powerful bursts of energy. This phenomenon has never been seen before, and it's got astronomers scratching their heads. The team led by Ekaterina Eilen at the Netherlands Institute for Radio Astronomy discovered this unique system using the European Space Agency's Cheops mission. They found that the planet's magnetic field is strong enough to influence the star's magnetic field, creating waves that travel along the field lines and trigger massive flares. It's like the planet is whipping a rope, causing the star to respond with a burst of energy. But here's the thing. These flares are not just harmless bursts of energy. They're actually eroding away the planet's atmosphere at an alarming rate. The planet is losing mass much faster than expected, and in about 100 million years, it could shrink from a Jupiter-sized planet to a Neptune-sized one. That's what we call self-imposed doom. Now you might wonder, is this a unique case, or are there more planets like HIP 67522b out there? Well, astronomers think that there could be dozens of similar systems in the nearby universe, and they're eager to study them further. The Cheops mission has opened up new avenues for research, and future missions like Plato will help us better understand this phenomenon. As we continue to explore the universe, we're reminded that there's still so much to learn about the complex relationships between stars and planets. The discovery of HIP 67522b is a fascinating example of how planets can interact with their host stars in unexpected ways. And who knows what other secrets are waiting to be uncovered. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. As we wrap up today's episode, I want to leave you with a fascinating story that will take us to the edge of our understanding of the universe. You know, there are some things in this vast expanse that we can't see, but their presence is felt through their gravitational pull. I'm talking about dark matter. Today, we got a glimpse into the invisible world of dark matter, thanks to the James Webb Space Telescope and NASA's Chandra X-ray Observatory. The image they captured is nothing short of breathtaking. It shows two massive galaxy clusters, known as the Bullet Cluster, with hot, glowing gas in pink and the dark matter mapped out in blue. Now, you might be wondering how scientists can map something that's invisible. Well, it's a bit like trying to see ripples on a pond of still water. You can't see the water itself, but when there are stones below the surface, the ripples distort their shapes, allowing us to infer the presence of the water. In this case, the dark matter is like the water, and the background galaxies are the pebbles. By analyzing thousands of galaxies in the Webb's images, researchers were able to weigh both the visible and invisible mass in these galaxy clusters. They even mapped the collective light emitted by stars that are no longer bound to individual galaxies, known as intracluster stars. This revised map of the Bullet Cluster is a remarkable achievement, giving us a better understanding of dark matter's role in shaping our universe. As we gaze up at the stars, it's humbling to remember that dark matter makes up about 85% of the matter in the universe. It's a mysterious entity that exists beyond our visible spectrum, yet its influence is felt throughout the cosmos. The James Webb Space Telescope has given us a unique window into this invisible world, and we're just beginning to unravel its secrets. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars. For in the words of Carl Starman, somewhere, something incredible is waiting to be known. Keep exploring, keep discovering, and we'll see you on the next episode of Star Chat.